The date and time types are useful for storing date and time related information. They include the date type, which is good for dates only, and dates in the range of the year 1000 to the year 9999. And the time type, which is good for times and time related values, not just time of day, give or take, for times in the range of plus or minus 840 hours. And the date time type for date and time combinations. The timestamp type is useful for event logging, and it's automatic. So every time you insert a row, it automatically gets updated with the time and date that the row was inserted. Let's take a look at some examples. We'll go ahead and create a table in the test database. This will create a table called dateTest with a date-time type for the date and a timestamp type for a timestamp called stamp. We'll go ahead and insert some data into it. This will insert into the table dateTest the column date with the value 2009-05-04. So that's May 4th, 2009, 3:31 in the afternoon. Now let's take a look at what we've done. So this goes ahead and it shows our two columns here, date and stamp, and it calculates the difference between these two values using the dateDiff function that we'll cover later. There we go. They are 16 days apart. The dateDiff function gives the result in number of days. So that's just a little example of how you can use these values and how they work. The date and time types are useful for handling date and time related information and storing that in your database. The bit type in MySQL is used for storing bit fields. So let's describe that by way of example. We'll create a table in our test database. We'll call it BitTest. We'll give it two columns, B1 and B2. B1 is a bit field with 8 bits, and B2 is a bit field with 10 bits. Go ahead and create this table and insert some data into it. What this does is it inserts into the table BitTest values for two columns, B1 and B2. The values are 4 on bits followed by 4 off bits, and off, on, off, off, on. The B here, before the quoted value, indicates that it's a binary value. And so it'll just be ones and zeros. Go ahead and insert that row. There we go. Now let's take a look at it. Now we're not going to expect this to be displayable data because we entered binary data. So what we'll see will be odd. And there we go. We have this odd little character there, and it couldn't figure out a way to display B2 at all. And so we inserted binary data. How can we look at it as binary data? Well, one way to do that is to tell MySQL that this is a number. And you do that by adding 0 to it. Any kind of math will tell it that it's a number. So you can just add 0 to tell it that it's a number without modifying the value. And there you see we got 240 and 9. But we entered binary values. Can we see them as binary values? And in fact, we can. We can use the bin function to see them as binary values. There we have the values that we entered. You'll notice that the leading 0 is gone from B2. So there's 10 bits available there, and we've really only used 4 of them. The rest of them are zeros, which is significant, but it doesn't need to display them. There's other number systems that are used for binary values, and just briefly I'm going to show them to you. So there's bin. I'm just going to show them with B1. There's octal, which is base 8. There's hexadecimal, which is base 16. And so there's those values in binary, octal, and hexadecimal. That's all the same value. So that's the bit field. It's useful for storing flags. If you want to store the state of a number of things in a very small space, it's really useful for that. You won't actually see it that often. It's something that might be used by programmer types, but you're not going to see it a lot in web work or in most of the database applications that you'll run across. And that's the bit field. MySQL does not actually have a Boolean type. It uses integers for Boolean values. So if you declare a column in your table as type bool, it will actually store it as tiny int. The word bool is an alias for the word tiny int. True is represented by an integer 1. False is represented by an integer 0. And in fact, the bit type is an excellent way to store Boolean values. Let's take a brief look at what integer values look like in MySQL. We can do this by simply testing for equality. If we ask, is 5 equal to 5, we should get 1 for true. Yes, 5 is equal to 5. And try something that we know is not equal. Is 5 equal to 7? No, 5 is not equal to 7, so we get a 0. So we can see that 1 is true and 0 is false. And that's really all you need to know about Boolean values in MySQL. You can store them in a bit field or you can store them in an int. And 1 is true and 0 is false. There are two different enumeration types in MySQL, enum and set, and they work very differently. So let's look at a couple of examples so that you can see how it is that they work. I'm going to create a table in the test database to show you enum. This will create a table called enum test with one column, color, of type enum with 3 possible values, red, blue, and green. Go ahead and create the table. And now let's insert a value. This will insert one row into the enum test table in the test database with the value red in the color column. There we go, and let's take a look. And there we have the one column with the value red. Let's insert a couple more. And another one for green. And so what we have now is we have 3 rows. One is red, one is blue, and one is green. The value of this is that these different values are actually stored in just 1 byte each. The enum type is actually just an integer, and it stores a number called an index. And when you define it, you've defined 3 possible values, red, blue, and green. And so it'll store a 1 if it's red, and a 2 if it's blue, and a 3 if it's green. So it takes up very little space. If you have a limited number of possible values for a column, then this is a great way to be able to still see them mnemonically, to be able to still see red, blue, and green, and to not have to translate it in your code, you know, that a 1 is a red, because the database engine will do that for you, and it does it very, very efficiently. So this is a very useful column type. I want to show you one other little quirky aspect of the enum type. If I try to put a value in here that is not defined in the declaration, it's not really going to know what to do with it. It can't store a 1 or a 2 or a 3. You can't store a 4 because it doesn't have it defined and it won't know what that is when it tries to read it. So what it does is it just silently stores nothing. And it's not even a null value. It's just empty. So when we go and look at this, we only see 3 values. There's actually a 4th row down here, and just because HTML doesn't display an empty table cell there, we're not seeing it. But if we do count, we'll see that there's 4 rows. There's 4 rows. So it's stored an empty value there for the unknown color. So this is just an important aspect to understand about how enums work. It'll silently fail effectively. I would have preferred that it gave an error and didn't allow us to insert a value that's not in the enumeration list when we declare it. But this is what it does, and it's important to know that that's how it operates. Now let's look at the set column type. We'll create another test table. This creates a table called setTest with 1 column, attrib, which is a set type, and it has 3 possible values, bold, italic, and underline. And these are attributes that can be applied in combinations. And so what set does is it allows you to have multiple values in 1 column, in 1 row. So one value can be bold, or it can be italic, or it can be bold and italic, or it can be italic and underline. It can be any combination of these 3 values. And the way that MySQL does this is it stores them in a bit field. This is really just another way to use a bit field with mnemonic values. And it's very, very flexible and powerful. And it allows you to use your bit fields and not have to do a lot of computation to figure out which bits are set and which bits are not set. Instead, you get these lovely mnemonic values for the bits. So let's go ahead and create this table, and let's assign some values to it. I'm going to go ahead and do several of these. I'm just going to cut and paste so that we can, let's say we'll do bold and italic. And we'll do another one with, say, bold and underline. And another one with, say, underline and italic. And let's do one more with underline and bold. We did bold and underline before. Let's do underline and bold so we can see how that works. The truth is that MySQL will always display them in the order that they were defined. So for underline italic, it'll say italic underline, and for underline bold, it'll say bold underline when we read them back. Let's go ahead and store this. We should have 5 rows in our table. And take a look. There we go. We have bold italic, bold, bold italic, bold underline, italic underline, and bold underline. See, underline is always at the end because that's the way that we defined it. If we go and look at our declaration, describe setTest, we see that that's the order that they're defined. Set, bold, italic, and underline in that order. So it'll always read them back in that order. So that's the set type. Set is very useful for flags. It makes the bit field usable by somebody who's not even terribly technical. And those are the 2 enumeration types that are available in MySQL. There's enum for 1 value per row, and they are stored as indexes in an integer field. And then there's setTest for multiple combinations of possible values, and they're stored in a bit field.